so we'll be starting right now. So welcome to the first lecture for Intro to iOS development. Today we'll be going over the basics of iOS development. So just an agenda, first we'll go over a little bit about us, so an introduction, and then we'll go over course logistics, so how this course is run. And then we'll talk a little bit about how you make iOS apps, and then we'll have a demo. So be prepared for that. And then finally, we'll wrap up with some action items for what needs to be done this week. So for the introduction.
Hello, my name is Hai Ying. I'm a senior studying CS. Currently, I'm working on iOS and web for course grab. Previously, I have worked on Ithaca Transit and Pair.
And I'm Amy. I'm a junior studying CS, currently working on iOS on Volume, and previously I was an iOS developer on Pair. And this is our amazing course staff, so Matthew, Noah, Reed, and Sergio. And so now that we're done with the introduction, we'll be going to course logistics. So lectures are 7:30 p.m. on Mondays, and we'll be using CampusWire for all course communications. The course textbook is linked here, and it's where you'll find all the syllabus, all the assignments, and lecture materials. And then we also have a course Google Calendar that has the lecture times and also office hour times. And these links, you'll be able to access them from the slides posted on the course textbook. Projects are due every Sunday. There's one drop, except for the first assignment and the last one, which is the Hack Challenge project. And you can submit late until Wednesday, but you'll get a 1-point penalty for every day that you submit late. And even though this is a student taught course, we still adhere to Cornell's academic integrity policies, so just keep that in mind. About enrollment, so the deadline to add this course is October 1st, and make sure that you enroll in Student Center in CS 1998 601 for 2 credits SU. You can enroll in 1 credit if you don't have enough credits in your schedule to enroll in 2, but just know that we will grade you as if you are enrolled in 2 credits. Some requirements, so we do require that you know programming, so either CS 1110 or any equivalent experience. It's completely fine if you're taking CS 1110 concurrently with this course. Just know that we won't be going over very detailed programming concepts. We'll just be jumping straight in with the Swift syntax. Also, you'll need Mac OS, so either you have a Mac or try to run it on a VM, but no guarantees that the VM will work. So your best bet is to have a Mac OS. There's also a link here in the slides, which you'll be able to access later if you do not have a Mac, so that you can try to install a VM. And also we require that you have Xcode 12, which is the most latest version of Xcode with Swift 5. So now that we're done with course logistics, I'll be talking a little bit about how we actually make iOS apps. So Swift is one of the languages that you use to make iOS apps, the other being Objective-C, natively, of course. So Swift is a language used to build iOS apps, and it's simple, expressive, fast, and safe. So if you compare here, this is Swift code and Objective-C code, and they both do almost the same thing, but you can see that the Swift one is just much more cleaner to read and write. If you see Objective-C, it's like a pointer to a string instead of just a regular string. And there's also these weird @ symbols and brackets. So it's just not that nice to read. And also I imagine it would be nice to write either. So Xcode is the IDE that we're using for making, building, and running iOS, macOS, watchOS, and tvOS apps. So make sure you have that installed. It was in the email sent before the class started. Yeah, so now we'll be going into the demo. Before I do that, does anyone have any questions about logistics, anything? Okay, so yeah, so this starter code can be found on the course website if you haven't already downloaded it. So you can go to the Cornell App Dev team page, go to courses, Intro to iOS Development, and it should be down here in the course textbook. You'll go to chapter 1, and it should be here. So you should be able to download it from here. I'll wait a few minutes if anyone has not downloaded it yet to download it. you'll see that I get an error because I can't assign to a value and the ID is a let constant. So it's a constant, so you can't reassign its value after it's been assigned. And there's type annotation. So you can explicitly assign the type of this variable. So I can say full name is string, type string, and my full name, whereas month is int and label is of type UI label. You don't necessarily always have to do this because most of the time Swift will know which type you're trying to assign it to. So like if you did var full name equals Amy Huang, and then you full name 2, and then if you do full name 2 equals like 9, and you try to run that, it'll say cannot assign a value of type int to type string. So it kind of like type inference that it was a type of string. So that's why you can't do that. And what happens if we try assigning a different type to the variable? So we kind of saw that earlier. If you do current year equals 2020, you see that you can't assign a value of type string to a value of type int, which current year is. So printing string and variables. So printing is almost like any other language. It's just print and then the value inside. So printing a string hello world, you can just do that. And if you want to print this string inside of a string, so like a value in type of inside of a string in other languages, you could do something like the current year is string of current year, and that will work. So if you try that, you see this, but in Swift, there's like this nicer syntax, which you can do / open parentheses, and then the value inside. So you don't have to explicitly cast it to a string type, and that will work as well. So you see it printed out both times. The current year is 2021. And arrays in Swift, there's two ways you can initialize them, but you have to, either way you initialize them, you have to explicitly declare the type. So this lecture numbers is of type int, and lecture numbers 2 is also an array of type int. So elements have to match array type. So if you want to add an element to an array, you can do that with append. So lecture numbers.append, very much like Python, and that will work. So if I print lecture numbers, you'll see that it now has a value of 1. But if I try to append the string 1, which it will not work because you're trying to append a value of type string to an array of type int. So that doesn't work. And you can also use loops in Swift. So they're almost like Python for num in 1 to less than 10. So if you do the less than as the last symbol in the ... sequence, you'll get an exclusive range. So you exclude the last value, which is 10. So if you try to append this, you'll append 1 to 9, which if I print this right now, you'll see it only did 1 to 9. But if you want to include the 10, you would do 3 dots. So it'd be 1 ... 10. And then you can see in lecture numbers 2, I print everything up to 10. If you want to remove from an array, you just use do the array dot remove at an index. So this will remove the value at index 0. If you see, if I print lecture numbers, it removed the 1 at the front. And if you want to remove from an empty array, you'll see that you get an error. So it says error execution was interrupted because of a bad instruction. So you can't remove an index that doesn't exist, just like any other language. And you can modify arrays by indexing. So right now the array is Yanlam Gonzalo, and if I wanted to change the first course instructor to Haiying and the other one to Amy, I would just index with 0 and 1, and then you can see that it was changed. Might take a while. Oh. It is taking a while, but yes. So originally the array was Yanlam Gonzalo, and now it's Haiying Amy. But if you try to change an index that doesn't exist, so if you look in this array, there's no index 2, you'll get an error. So it'll say like you tried execution was interrupted because like you can't change an index that doesn't exist. And if you want to add something, like in this case, if my intention was to add Amy to the end of this course instructors array, I should do append instead. So this would be course instructors.append somebody. So if I print it, you'll see that I get course instructors with somebody at the end. And so next question. Oh, at this, does anyone have any questions about anything at this point?
Yes.
When you were making the arrays for lecture numbers 1 and 2, what's the difference between
Which line specifically? Oh, 27.
Oh, here.
Oh,
Okay.
here.
So I don't think there's any difference that I know of, just syntax. It's just like personal preference, whichever one you think looks nicer. But yeah, I usually prefer to use this one. I don't know if you know there's a difference.
Yeah, I think like Amy's saying, it's just personal preference. Both works, same thing.
This one's like nicer if like you want to already initialize this
Mhm.
array with some values. So like you can just do this. Whereas like the other syntax, I don't believe you can. So yeah. Yes. I'm sorry, we can't hear you. Can you speak up a little bit? Oh,
Oh,
is it
oh,
not-
zoom.
yeah.
It's a little small.
Is that better?
More.
Oh. Is that better? Okay. Sorry about that. Does anyone else have any questions?
Also, let us know if we're going too fast.
All right, I'm sorry. I'll slow down. Yeah, so we went over arrays, and then lecture numbers 2. Okay, I don't know why it's saying this.
You forgot to set it equals to the.
Oh yeah, I deleted it. Okay, cool. Thanks. Yeah, so now we're going into dictionaries. So dictionaries are like other like Python. So you have a key and you have a value, and the keys don't necessarily have to have the same type as the value. So in this case, I'm initializing 2 dictionaries called pantry and pantry 2. So these are just 2 different ways to initialize a dictionary. There's no real difference in use. It's just whatever your personal preference is. And just this one is nicer if you already have like preset values like key and then value. So that's the only difference that I can think of. Oh yeah, so make sure you have the colon there. And so to add a key value pair to the dictionary, you just have to do pantry and then the key that you want to add and then the value you want to add. So if you see pantry before was an empty dictionary. So now if I print pantry, I get a dictionary with the key apples and the value 2. And then if you modify it, so you can modify the same with like passing in the same key and then giving it a new value. So if you print pantry now, it'll have apples 4. So like I said before, you can also just directly create it just like this. So pantry 2, if you already know what you want to assign it to, you can just give it the key, the value, comma, other keys and other values. And you can iterate over the dictionary with a for loop. So you can do for food and quantity in pantry 2. So we named these variables food and quantity, but it's just the key and the value. So I'm iterating over this array, and then I'm going to print out the value. So I'm going to say I have like 5 oranges, 10 apples, 2 chocolate bars. So it's printing out the keys and the values. So functions in Swift, the syntax is funct and then the name of the function and then parentheses and then curly braces. So this function just prints something, like literally something, the string. And to call a function, you just have to use this syntax. So the name of the function plus open parentheses, close parentheses. So if I call this function, you see it just prints something. So if you want to declare a function with arguments and a return type, you have to pass them in the parentheses. So in this case, this function add has 2 parameters. So it's a and b. A and b are both ints, and the return type of the function should be an integer. So this function just adds a and b. And we can call and store the result of the function in variables. So let's add 2 and 3 equal add a 2 and b 3. So you can print out the values. So this prints out 5, and then if you print the other one, you see that it prints out 7. Just like other language, well, Swift is actually very type safe. So actually you can't pass in, like say this is integer, but if I wanted to pass in a string, then it wouldn't work. So it would yell at me and be like, can it convert value of type string to expected argument type int? So structs. Oh, does someone have a question? Oh, does anyone have any questions? Good. Okay, cool. So structs and classes. So classes and structs are defined structures used to create objects that can meaningfully represent data. So many of you who probably take Python or are taking Java know that classes like in other languages. So this is kind of almost the same. We just have something called a struct in addition to classes. So think of it like blueprints for like houses. Like say like you want to build a house, so you would have a blueprint for it, and this blueprint would be like, oh, like how big is this house? Like what materials should I use? Things like that. So in this example, say like we're designing an app for Netflix or Hulu, and we wanted to organize the data for the episode of a show. So here I'm creating a struct called episode, and it has properties of name, which is a string, and duration, which is a float. So like the duration in minutes. And so the way you declare a struct is you just the syntax of struct episode curly brace and then the variable properties. So instantiating instances of our struct, you can just do like var episode 1 equals episode. So I can just make another one, episode 3, or episode 5 equals episode. So the nice thing about Swift is a lot of the things will autocorrect, like fill in for you. So you can just say episode name, and then I'll give it a duration of like 15. So that would be how you would declare create instances of our struct. And then to access properties, you can do it with just the dot syntax. So if I wanted to print episode 1's duration, I would just do print episode 1's duration is episode 1 dot duration. So if you see that, it'll print this. And so classes are a little different. So classes are almost the same. You just use class instead of struct here. But the main difference is that classes need initializers. So you need to initialize all the variables and all the properties that you add to this class. So in this case, I have to initialize the name and the episodes. This syntax is almost like Python. So you just do init, open parentheses, and then the properties within, and then just assign them like this with the self.name equals name, self.episodes equals episodes. In classes, you can also define functions. You can also do these in structs. So it's almost the same. You can just like name the function with funct and then the name of the function and then define it in here in the curly braces. To create an instance of a class, it's just like a struct basically. So you just do let podcast equals podcast and then the name and fill it in. So I can do let podcast 5 equals podcast. And can just do podcast and then episodes. I'll give it an empty array. To access properties of a class object, you do it's almost the same as a struct. So you just do podcast.name. So if I print this, I'll print podcast name is intro to iOS. And then also if I wanted to call this function, I just had to do podcast.playPodcast. And if you see this function, it just prints this episode is sponsored by name. So the podcast is name. And you'll see that it prints this episode is sponsored by intro to iOS. Oh, yes.
Could you go into a little more detail about the difference between structs and classes and where you use them?
Yeah, so here I'm going to be talking about the difference between the structs and classes. So the difference between structs and classes are structs are value types, whereas classes are reference types. So if you like a good way to think about it is like if you like say you instantiate a struct, say episode, right? And you try to declare another variable called episode 2 and you assign it to episode, then episode 2 will not have a pointer to episode. Rather, it'll create a completely different copy of episode, if that makes sense. Whereas if you did the same thing with the class object, if you did episode like podcast and then you assigned it to podcast 2, you did podcast 2 equals podcast, then whenever you change podcast 2, you will change podcast because they point to the same like place in memory, kind of, if that makes sense. If that doesn't make sense, it'll make a little bit more sense with this example. So here I instantiate two variables. One is episode 3 and the other is episode 4, which I assigned to episode 3. So if I print both of them here, episode 4, you'll see that they both have the same value. So it's structs and duration is 5.0. And then here I do episode 4 dot duration equals 14.3. So like, I guess I kind of already talked about this, but since we know that episodes are structs, like, can anyone tell me what would happen to both episode 3 and episode 4? Yes.
Episode 3 will be unchanged, but episode 4 will have 4.3.
That's exactly correct. And we can see it if we print out their durations. So you see episode 3's duration is 5.0 and episode 4 duration is now 14.3. So episode 3 didn't change, but episode 4 did. And if we do the same thing with classes, so podcast was a class object. So I do podcast 2 and I assign podcast 3 to podcast 2. I change podcast 3's name to a newer podcast, right? And I guess, can anyone tell me like what change do you expect to see for both podcast 2 and 3? Yes.
Both podcaster and podcasting will have a new podcast name.
Yeah, exactly. So because they point to the same like place in memory, when you change podcast 3, you change podcast 2. Whereas with the structs, like these two are completely different places in memory. So when you like assign it here, episode 3 basically gets copied and it's like separate. So that's the main difference between classes and structs. Does anyone have questions about that after this? Okay, now I will be talking about optionals. So Swift has this thing called optionals, and a way you can think about an optional is basically like it's like a box, and you don't know if there's going to be something inside of it or not. Like it could be empty or there could be something inside. So first, like a non-optional declaration is like just a regular variable. So you just do var input string, string equals hello world. Like there's nothing special about this. But so I did say empty. Basically what I mean by empty is it could be null. Other languages call it null, but Swift it's nil. You can't assign nil values to non-optional variables. So if I try to assign input string to nil, you'll see that I get an error because nil can't be assigned to type string, right? If I wanted something to be optional, I would have to declare it to be optional. So var optional string, you just add this like question mark at the end of the type, and then it'll be optional. So an optional string can still have a valid value, but you can also assign it to nil, which is basically like nothing. So you see like I don't get an error there. So if you have variables that are sometimes optional, you will not necessarily know while using them if there's something inside there. So what you have to do is like unwrap the box kind of and like see if there's something inside there. A non-nice way to check if something is nil is by doing this syntax. So if you do if optional string does not equal nil, and then you print the string value wrapped in the optional is optional string. So the reason why is because like if you look at, well, one of the reasons why is because if you look at this, you'll see that when you print it, it's okay. Oh, I set it to nil. Oh, thanks. Okay, so it didn't run in here because I did send it to nil, but if I unset it, then you'll see that it prints the string value wrapped in the optional is optional hello world. And like if you're getting something back from like say like a database or something and it's like optional, like you might not know if there's something in there and you like just directly print it, like this might not be nice for like a user. So a better way to do things is to unwrap them. So there's two ways to unwrap them. First, we'll talk about if let. So if let is kind of like the syntax is if let unwrap string equals optional string. So you pass in the string that could be optional or the value of a variable. It could be, it doesn't have to necessarily be a string. And then this is what you will name it like locally. So locally, you'll name it unwrap string. And basically, if optional string is a valid value, then when you unwrap it and put the value inside optional string, unwrap string, sorry, you'll be able to access it inside this code block. So then optional string is currently hello world. So if I run this, you'll see that it says the value wrapped in the optional string is hello world. So it doesn't have like this optional parentheses around it. And so if you set it to nil instead though, you'll see that like as before, it didn't run in here. Like I can see like prints like after if let's, and you'll see that this printed, but this didn't print like again. So it's because this was nil, so nothing in here got run. So you only run the code inside the block if it turns out that this string was, while it was optional, there was a value inside it and you put it in unwrapped string. And so you can also chain on optional unwrapping. So if you have two optionals and you want to unwrap both of them, like you can just use this syntax. So if let unwrapped 1 equals optional 1, and then let unwrap 2 equals optional 2. So now I can print both of these and access both of these inside this code block. Does anyone have any questions at this point? Yes.
What is the keyboard shortcut you use to comment and not comment stuff?
Oh, I use command forward slash. Is it forward slash?
Yeah.
The one, yeah. So, oh yeah. Oh, okay. Okay. So an optional is basically like it can be null or it can have an actual value. So if you think about it, it's like if someone gave you a variable, right? It's like giving you a box, and this box could be empty or not empty, but you want to take the value out and like use it, right? So that's why we unwrap optionals. Does that make sense? Yeah. Okay. Does anyone else have any questions? Okay. So now I'll be going over the second way you can unwrap optionals, which is with guardlet. So this is like a function called unwrap. I pass it an optional string, and you can tell it's an optional string because of this question mark. So guardlet, the syntax is guardlet unwrap string equals optional string, which is the string that we thought was optional that's passed into this function, else this code block. So basically what this is saying is if you can unwrap it, then unwrap it and store it in unwrap string. If you can't, then just do this, which is print and then return. So the nice thing about guardlet versus iflet is that if you have like a variable that you know you'll be using for like a large chunk of code and you don't want to just like restrict it inside one block, guardlet is nice because after you unwrap it, you can use it anywhere inside this function. Whereas if this was an iflet, you would only be able to use it inside like the brackets of the iflet, if that makes sense. So now I can use this unwrapped int, which has value of unwrapped string. So this is what this function should be doing. So if I like uncomment this, well, this one won't run. So it'll just say guardlet returns out of the function because this was nil, right? So it went into this else case. But this one is optional, but it does have a value. So if you run this, you'll say, now I can use the unwrapped int, which has a value of unwrapped string. And in addition to iflet and guardlet, there's also guardvar and ifvar. So guardvar would be like guardvar unwrapped string 2 equals optional string. Return and print guard var returns out of the function. So the difference between guard var and guard let, not a big difference, but you'll see by this let versus var is that guard var, the unwrapped string that you get from it is mutable. So I can do like unwrap string 2 equals like hello, and that will work. If you try to do this to the unwrap string let, it won't work. So if I did like unwrap string equals hi, like if I try to run this, you'll see that it says cannot assign value to unwrap string is a let constant. So similar syntax with if let. So it's usually like if let, but you can do if var unwrapped string equals input string or something like that. Yeah. So there's also another way to get the optional out. This one is like most preferable if you have a default value. Like if you know that if like this box is empty, like I just want to use this value. So the syntax is let the variable that you want to like after you unwrap it equal to the optional string, which could be nil or could not be nil, and then the 2 question marks and then your default value. So in this case, I'll say optional string is nil. So if I do that, if I do if unwrapped string equals with default value equals default. So if I run this, you'll see that unwrapped string was nil. Oh wait, sorry. Unwrapped string default. Yeah, so unwrapped string was nil. It went into the if case because it was nil. So then when I did this, it was nil. So it just chose the default value. And then inside the if statement, it printed here. So if I set this to like an actual value, you'll see that when I run this, I get unwrapped string value hello because it got the actual value outside of the box, if that makes sense. So it wasn't default, it was the else case. So you can also print it directly. So this value, you can also just do this. You don't have to do the if statements, and then it'll just print hello. There's also force unwrapping in Swift, but force unwrapping is basically like, I will just forcibly get this value out of the box. So it works if, say, like this value that you're trying to force unwrap is like actually a value, if you can guarantee that it is a value. So if you print this, like it'll be fine. So it says, I'm confident the optional has a value in it. It is hello world. But say this force unwrap string somehow got assigned to nil, which is nothing, right? So then if I try to run this print statement where I force unwrap it, I get this error, right? It says execution was interrupted. So we don't recommend force unwrapping. It's always better to use if-let or cart-let statements. So like just try not to use force unwrapping. And so dictionary. So like, how can we tell if the key is in a dictionary? So the values returned are like optionals. And if the key doesn't exist, then you get nil. If the key does exist, then the value will be returned. So if you remember the pantry, there were no pairs in the pantry. So like if you do this, where's the pantry? I think the pantry I might have, wait, no. So I can't comment the force unwrapping. Yeah. Okay, so if you try to force unwrap these pairs, that you'll see that like you get this like fatal error because it like you unexpectedly found nil. So then you have to unwrap it. So if you unwrap it, then you'll get that nothing prints, even though like after pairs, right? So you see that like nothing prints because we tried to unwrap it and there was nothing. We had in our pantry, we had no key called pairs. So this is always like better. But if you did have like stuff in your pantry, like for example, we remember the pantry had apples. So you can do if let value equals pantry apples and then it'll print. I have like 4 apples, right? So does anyone have any questions at this point about optionals? All right, so now we'll be going into enums and case statements. So before I talk about them, I want to like introduce like an example that like will show why enums are really nice. So say you have like this struct that will represent objects of coffees. Coffees do have other qualities, but I'm just going to use size. I'm just going to add size for now. So a coffee, say, can only be tall, grande, or venti, right? So if you wanted to make these coffee objects, you would have to hard code the string values, right? So you'd be like, let coffee equals a coffee of size grande and then a coffee 2 of size venti, right? And then say I wanted to write this function that given a coffee, I want to print what size it is, right? So I do if coffee.size equals grande, then print grande coffee, else if coffee.size is venti, then print venti coffee. So it works if I do this, right? So grande coffee, venti coffee, right? But what if the coffee size was like misspelled? So like say I have a bad coffee that I named tall, which is a valid value, but I don't account for it in my print statements. So then if I try to print coffee size, and like this is just a marker just to show that I did run this line of code, you'll see that nothing prints. I don't get like tall coffees. So this is really bad if you have, this is a really bad way to implement if you have like certain cases for a value. So like this size can say like only be like grande or venti. And like it's always like not good to hard code it. So that's why enums are really nice. So here I'm declaring an enum. So like say you have a font and a fonts can only be small, medium, or large. So the way you would create an enum from this like enum declaration would be to do, there's 3 ways to do it. So you can do let small font size equals font size dot small, which is like the name of the enum dot small, or medium font size dot medium, and you can explicitly declare the type of the font size, or you can just do dot large. Like you don't need the enum declaration, the enum name in the front. So enums are great for switch statements. So here's a function called print font size. So I'm passing in a font size and I can just switch on this font size. And I have cases for small and medium. So if the font size that I'm passed in is small, then I'll print like I am small, else I'll print I am medium. And then we also have this default case where if the font size for some reason is neither small or medium, it'll print I don't know, right? Yes.
Did you say what a switch statement is?
Oh yeah, so switch statement is basically kind of like I like to think about it as like a built-in like case checker. So like font sizes can be small or medium. The way you can write them is like you just do switch, and then the thing you want to switch on, which in this case is font size, and then you do small, and then the code here. And you don't have to implement all of them if you have the default case. So if you have the default case, you can just do defaults. I'll comment this out so I don't have duplicates. But if you see here, like I only have small and default, right? So when I pass in a font size, it like I'm saying like it has to be small, and if it's not small, then I'm just gonna give the default value, return value. But if I get rid of this default, you'll see that it'll yell at me. So to say switch must be exhaustive. So if you ever forget, like you can just do this and it'll fix it for you. But say you don't want to, like for some reason, account for large or medium sizes, like you don't care if it's small or medium, you only care if it's small, then you can also do like defaults, which was what we had before. Does that make sense? Yeah. Yeah, basically, yeah. Does that make sense? Oh, yes.
What's the difference between a switch and a default? Is it shorter code than default?
So you can definitely do this with if else as well. Like if else fonts, if font
Yeah.
size equals dot small, but then you just get like a bunch of if else, which is kind of ugly.
Yeah, you can do this, but it's just like nicer to do it with enums because it's like just switches. Yeah, but you can only switch on enums. You can't switch on like any other values, types of other values, right? Or
You could technically,
You
yeah.
can?
Yeah, you can.
Oh.
Like if you have a string, let's say, I don't know, it's just some string, you can also like check if the string is some value with a switch.
okay, yes. But yeah, switches are just nice for enums. So I'm just gonna get rid of this and uncomment this code. So if you see here, I only implemented switch statements for small and medium. So what does anyone know what will happen if I run this print font size, large font size, which was this one? Yes.
Say I don't know. That's the default case.
Yeah. So yeah, it'll print the default case. I don't know because I didn't implement the large font size. But if I wanted to, I can just do large print. I am large and get rid of this case and it'll be like fine. And then it'll say taking a while. It'll say I am large. So yeah, that was it for lecture. Does anyone have any questions at this point? Yes. Yes, this lecture is
Yes.
recorded. It'll be posted on YouTube, and there will be a link from our course textbook page. Before you go, we have some action items. Where's the keynote? Oh,
Just go to.
okay. Before everyone goes, oh yeah, if you have any questions afterwards, feel free to come up and ask. But before that, we have some action items for what you need to do this week. So make sure if you're not enrolled to enroll in CS 1998-601 as soon as possible. The ad deadline is October 1st, so it is coming up. And make sure you're added to the Campus Wire and CMS. That's where you'll have access to all the assignments and also be able to ask questions. And the Project One handout is in the course textbook. It's due this Sunday, September 26th at 11:59 p.m. on CMS.
And then next lecture will actually be building on a simulator, which is like a mock of your phone. So yeah, make sure to come because that will be more exciting. Yeah.